Alright, so today we're going to look at something really short and simple just to see if everything is going to work out right, since this again will be my first time trying to actually launch the video. So we're going to look at circular arc length. Okay, just like with squares, triangles, rectangles, we are able to actually give the perimeter of that. But when it comes to circles, we don't say the perimeter of a circle, we basically say the circumference of a circle. So which gives us a way to actually measure the arc length. Okay, and we know the circumference of a circle is 2 pi times the radius. So when we're talking about the arc length, we're talking about the where the arc intercepts at the radius of our central angle. And remember, a central angle is at the center, and the rays lie within the circle, and it ends at the end of the circle is what our central angle belongs to. So we have this formula: S equals R times theta, where R is the radius, theta is the measure of the angle, which is the central angle, and it's in radians. If it's in degrees, you must convert. And then S is our actual arc length. Okay, so this is really kind of straightforward. The only difference here is if you have to manipulate this. We can find what R is by basically, how do we get R by itself? Divide S by theta. If we wanted to find out what theta was, we would take S and divide it by the radius. Those are your manipulations here. These are your manipulations. Manipulations. You guys know what I'm talking about. Alright, so let's do an example. If R equals 1 centimeter and theta equals 70 radians, what is S? So S equals 1 times 70, which gives you 70 centimeters, because the radius was measured in centimeters. You didn't have to put that in the calculator at all. Okay. Example 2. Let's find the radius. Given S equals 2.5 centimeters and theta equals pi over 3 radians. So if we're looking for R, we're going to use R equals S over theta. So that's 2.5 centimeters over, and theta is already in radians, so we don't really have to do anything with that. So this becomes pi over 3. Now, because we have a whole number, well, it is a decimal, but it's still a whole number over a fraction, we're going to use keep, change, flip. So we're going to keep our decimal, and we're going to flip or take the reciprocal of pi over 3, which will give us 3 over pi. And then 2.5 times 3. 2.5 times 3 is going to give us what? 7.5 over pi, and then this is going to be centimeters. So that's what our radius is, 7.5 over pi centimeters. And you can have pi in the denominator. You can have pi in the denominator. Okay. Example 3. S equals 2 meters And theta this time is going to be 125 degrees. And so we're going to look for R. Okay, I'm not going to have enough room on this page, so I'm going to switch to another page. So I just carry my example up. I said 2 meters, and R was a question mark, and theta was 125 degrees. So we're looking for R again, so that's going to be R over equals S over theta. But before we begin, we got to convert our theta to radians because it's in degrees right now. So we know that conversion factor is pi radians over 180 degrees, and we can multiply now that by 125 degrees. And that was from the lesson from today. So pi radians times 125 over 180. I give you a minute to get that and leave it as a fraction. All right, 25 over 36. So we end up with R equaling 2 meters over 25 over 36, and that's 25 pi. Same type of problem what we just got finished doing, where we have a fraction at the denominator, so it's going to do keep, change, flip again. So we keep our numerator and we take the reciprocal of our fraction. And I think I froze. Okay, so I'm back up. So that's going to be 2 meters times 36 over 25 pi. And then 2 times 36 is 72 over 25 pi. And because we were using meters, we say meters. So our radius is 72 meters over 25 pi. All right. One more thing I'm going to do. I did want to go into course bearing with you, but for sake of time, and I wanted to really do a short video to see if it was really, working and we can get it going. I'm going to do this last example, and it has to deal with revolutions. Okay, one revolution is equal to 360 degrees, which is also equal to 2 pi radians. Okay, basically all it's saying is I have a circle, and we know a circle is 360 degrees. Not a very good circle, but you guys understand. If I go all the way around this circle, that's 360 degrees, or we could say that's one revolution, or we could say it's 2 pi radians. So those all mean the same thing. Okay, so if you turn your books to page 357, we're going to look at problem number 44, which is dealing with automobile design. Okay, and it's asking us to find the speed of each vehicle in miles per hour when the wheels are turning at 800 revolutions per minute. 800 revolutions per minute. So we got a lot of conversions that we have to do there because they gave us 800 revolutions per minute, and they want us to convert that to miles per hour. Okay, this is where that previous math comes in handy and those conversions, but you can always look these conversions up. So we got revolutions, we got got to get miles, and we got to get hours. Well, we know that 1 hour is equivalent to 60 minutes. We know in order to get miles, we know that 1 mile is 5,280 feet. And we can check that to make sure. I'm going to even check it. 5,280 feet. Yes, 1 mile equals 5,280 feet. So I got inches, revolutions, I got to get miles, and I got to get hours. Okay. They also gave us diameter, and our diameter is in inches. So that means that I need to know that 12 inches equals 1 foot. That way I can get my miles. All right. So we're going to look at the Ford Taurus. Did I leave out a conversion? I did. 1 revolution. We don't need degrees here, so we're going to say 1 revolution equals 2 pi radians. And there's one more conversion that we have is 1 radius is equal to 1 radian. All right, so now we have our conversions. All right, so 800, let me use a different color, revolutions per minute. So we got to change this to hours. So we're going to put 60 minutes versus 1 hour. We got to get rid of this revolutions here. And so how are we going to get revolutions? So they gave us 1 revolution equals 2 pi radians. We have diameter, so we need the radius. So the diameter for the Ford Taurus was 26.16 inches. So that means the radius is half of that. Half of 26 is 13. Half of 16 is 8. So we say 0.8 inches. Okay, so then 1 radius is equal to 1 radian. So that means that 13.08 inches is equivalent to 1 radian. Okay, we needed that. Times revolutions need to cancel out. So we need 2 pi radians over 1 revolution. And you probably would have done this one first and then did the inches. It doesn't really matter the order because multiplication is commutative. It doesn't matter the order that you multiply in. You're going to still get the same thing. Times, we got to get rid of these inches. So that means that 1 foot equals 12 inches. And last but not least, we know that 1 mile equals 5,280 feet. Okay. What I like to do next is go ahead and cancel out my units to see that everything cancels out and I have miles per hour. So minutes cancel out with minutes, radians with radians, revolutions with revolutions, inches with inches, and feet with feet. Only thing I have left on the top is miles. Only thing I left have on the bottom is hours. So in your calculator, you can go ahead and multiply that out. I'll give you a minute. All right, because they gave us our diameter in decimal form, we're going to keep it in decimal form. So that means this is the only time we can go ahead and use pi in the calculator, or like I said, if they tell you to give the decimal place for that. So we're going to go to two decimal places. So when I did the top, I got a really big number. Most of you probably just put it in the calculator and got the final answer, which that's okay too. And we're going to divide this by the bottom, and the only thing I have to do on the bottom is 5,280 times 12, which is 63,360. And when you divide that, you end up with, what do you end up with? Okay, two decimal places, 62.26 miles per hour. So the Ford Taurus with this tire diameter can actually go 62.26 miles per hour. Okay, and that's it for that. So here, which is a lot of conversions, and that's basically when we talk about our angular motion and our circular motion. All right, so what I want you to do tonight, very simple, not too many problems, is page 356, problems number 25, 29, 35, and 53. Okay. All right, you guys have a good night. Please let me know if you have problems looking at the video or seeing the video. Send me a comment in my comment box on the website, and make sure you jot down your notes if you have any questions about anything that we went over or you still didn't understand. Have a good night.